So this segment is going to be discussing behavior of gases. A lot of the stuff you're going to hear today, you probably have seen it in real life, or you've read about it, or even discussed it in other sections of chemistry. One of the things that I want to show you guys is something more visual, and this is actually a simulation. Um, this box right here represents a chamber, okay? And one of the things about gases is that when you change the pressure of a gas, it can either increase or decrease volume or increase or decrease temperature. So let's take a look here. We're going to go ahead and add some particles of gas into this chamber, okay? And the first thing we're going to look at is what happens to pressure if you increase volume. So this little handle right here is going to change the size of our container. And this gauge right here is showing you what happens to pressure. So right now our pressure is fluctuating between 9.2 and 10.4 atmosphere. So let's go ahead and increase volume. So as I increase volume, pressure is going to decrease. That's what's happening here. Okay, I start to increase volume. I'm starting to decrease volume and pressure is increasing. I go back to increasing volume and pressure is decreasing. So it has a inverse relationship. So if you increase volume, pressure will decrease, and it works the other way around. If you increase volume, pressure will decrease. And this is called an inverse relationship, okay? So a lot of you've seen this in math. So I'm going to write inverse, okay? And that means when pressure decreases, volume increases, okay? Same way if pressure increases, volume decreases. Okay, if we were to write a equation, it would look something like this. It creates that inverse relationship. Okay, if we were to do a graph where this is pressure and this is volume, okay, as pressure increases, volume is going to decrease. And if you guys know, when you draw an inverse, it's going to look something like this, okay? And this is known as Boyle's law. He was the scientist who discussed this or discovered this. Another thing we could look at is if you increase the temperature, what happens, okay? So let's take a look again here. Let's say, so if you guys look up here, here's the temperature, okay? So we're at 1260 degree Kelvin. If I were to, so the question is saying if you were to increase the temperature, here's the pressure, okay? And I'm gonna add heat. If you guys notice, this number is going up, so that's pressure. So that means as I increase temperature, pressure also increases, okay? So going back to this is going to be different now. This is going to be a direct relationship. So the one before it was the inverse or indirect, and this is going to be direct relationship. So I'm going to write direct. Okay, so what that means is as pressure increases, our temperature is also increasing. So if we were to do pressure and temperature, it would look something like this. It would be a straight line going up. Okay, that's Lusak's law. It also works, and I don't want you guys to get confused. The direct relationship means that if you were to decrease pressure, temperature would also decrease. Okay, so whatever pressure is doing, temperature is going to do. Another one we could look at is what happens when you change the volume of something. So a lot of you guys, pressure and volume is something that you might be already familiar with. Think of a balloon. When you're blowing a balloon, you're increasing the volume of the gas in the balloon by giving it more space when you're blowing in more oxygen into it, right? You can pop a balloon by increasing pressure. So this is all things that you guys have probably seen or done. So the first thing here says, if you increase the temperature, what happens to volume? Okay, so we'll go back over here. I'm gonna reset all of this. I'm gonna add some particles here. Okay, let me add a little bit more. Okay, so they want to know, or we're looking at volume and temperature. So here's my volume is this size right here, and if I decrease volume, okay, temperature rises. So that's one thing I want you guys to see. It's weird because when we decrease, it's not going to really do anything here. That's the only thing about the simulation. But again, here's the volume. Temperature's at 300. I didn't add any heat. And if I decrease the volume, temperature rises. Okay, so if temperature increases, the volume increases. And that's the one thing that, let's see if we could try it here. If I were to, yeah, it won't. It doesn't show you. But one thing you could do is if you were to have a balloon at home, if you were to put it in hot water, make it really, really warm, and you measure before and after you heated up the balloon, you will notice that the balloon will increase without even adding more oxygen. It would increase. A lot of the times, I don't know if you guys ever noticed, if you buy a balloon in the winter, and this happened to me one time. I bought a balloon. Both my daughter's birthdays is in the winter. One's in December. The other one is like in January, and really cold outside. I bought a whole bunch of balloons. By the time I got home, they looked kind of deflated. And this was in the car. When we got inside and I brought the balloons inside, they looked inflated again. So it wasn't that it necessarily lost air, it's just the change in temperature affected the volume of the gas particles in the balloon. So if you increase temperature, so does volume. So this has a direct relationship. So this is a direct relationship. Okay, so volume increases, temperature increases. Okay, volume decreases, temperature decrease. So whatever volume does, temperature does. Okay. If we look at, and this would be Charles' law. Okay. Another one is what happens if you increase pressure. Oh, this was a typo. If you increase moles. So we're going to clear this out. And we're looking at moles and volume. So here's my volume. Okay. I have this small container. And it's not a container that expands. So it's not elastic. kind of like a balloon. This is just a rigid container. So if I add a whole bunch of particles, I keep adding, I keep adding, I keep adding, just a whole bunch of moles of particles. Eventually, if this container cannot expand, you guys are going to see something, right? It's going to break. So this one pops, okay? And that's what happens when you have so many moles in a small container. So therefore, if you increase the number of moles, volume will also increase. So that also has a direct relationship, okay? And this is known as Avogadro's law. And just think about it. If you're blowing air into a balloon, if you keep blowing and you keep blowing, what happens to the balloon? The balloon is increasing, and eventually it won't be able to expand anymore, so it's just going to pop, okay? So I wanted to take a look at this video real quick, and it's a really interesting video. Let me see if I can press play. So just gonna mute it. Okay, so here's a balloon, and the chamber that he's using actually is able to decrease pressure. Okay, so as he takes out all the oxygen in the container, the only oxygen that's going to be left is what's in the balloon. And what happens is that pressure is decreased, so therefore that volume is going to increase. It has an inverse relationship, and this is what's happening. So it's pretty cool. Another phenomenon where you could see this is if you put a marshmallow in there, the marshmallow will expand, and the moment you let all that air back into the box, everything is going to reduce again in size. Okay, so I hope this lesson helps. If you guys have any questions, feel free to let me know. I hope you guys have a great day.